Hi, this is R.Maheswari, working as an assistant professor. I am here to discuss about wireless communication. In this video, I will be discussing about ancient communication methods, history of communication, and certain basic definitions and concepts in wireless communication. Let us look into the evolution of communication. Now, what exactly is communication? Communication is the act of conveying information from one place to another, from one person to another, or one group to another through the use of mutually understood signs, symbols, and semiotic rules. The first recorded form of communication took place in the year 1800 BCE when Chinese soldiers leveraged smoke signals to warn their comrades 500 miles away from the Great Wall of China. Some tribes use special drum beats to send warnings or important information. Later on, pigeons have carried messages for thousands of years and can deliver messages much quickly than people. Pigeons were reliable for delivering messages because they always find their way home. Ancient Romans delivered messages on horse ride, which they found to be an efficient and fast way of communication their messages. Fast forward to modern times, we can see a plethora of ways with which we can send our messages over the world. The mode of communication is so vital. After computer evolution, it takes only seconds to deliver the messages. Okay. So, we have seen the ancient history of communication. Now let us look into what is communication, what are its types. Right? So communication is nothing but transferring of messages from one place to another. It could be of two types. One, it could be wired communication or wireless communication. What do you mean by wired communication? For example, in this picture, you could see a computer has been connected to a printer using wires, right? And it is connected to an internet hub using wires. So this forms a wired communication, right? Later on, the second one, what is wireless communication? For example, if you want to transfer a content from one mobile to another mobile, are we using wires for connecting? No, we're just sharing the data from one mobile to another using a Wi-Fi network, right? Or using a technology called as Bluetooth technology. So this is wireless communication. Using wires is wired communication. Now, introduction to wireless communication. See, I'm going to tell you about only wireless communication over here in this full lectures. So what exactly is wireless communication? Wireless communication is a transfer of information or power between two or more points that are not connected by an electrical conductor. So as discussed earlier, I told you, see, you're not going to connect any devices using wires. So your wireless communication constitutes a satellite network, your cellular communication, your wireless LAN, and all your wireless networks. Okay, then let us discuss the history of communication system. So as we told you already, your communication started using smokes, pigeon, then the Morse codes, and again it has been developed from telephone, mobile phone, internet and mail, and now it is going to be handled devices and whatnot, right? And here in the tabular column, I have showed you the history of communication. The history of communication started with an understanding of magnetic and electrical properties observed during the early days by Chinese, Roman and Greek cultures, and experiments carried out in the 17th and 18th centuries. A short history of wireless communication is presented here in the tabular column. So your communication system, it started right from the year 1880s, 97, 33, 38, 46, 56, 64, again in 64 where your full duplex communication was enhanced in 1969, then from 82, 84, 86, 88, 92, 93, 94, 95, 96, 97, 99 where your powerful WLAN systems was evolved such as Bluetooth, which is working at a frequency range of 2.4 megahertz. And later on, now we are using 5G, 4, 3G, 2G, 5G all. Now, leave about the history. We'll discuss about the components of a wireless communication system. So, how the signals have been transmitted from the transmitter to the receiver? How it is going to be transmitted in the form of electromagnetic waves through what medium we are using here? Air is the only medium. right? So you're going to just transfer the messages over the air. So the components, it includes your transmitter, your receiver, and only the air and the information in the form of electromagnetic waves. What are the terms, basic terms in wireless communication present? We go for propagation, the modes of propagation, multipath propagation, fading, shadowing, and path loss. Let us discuss in detail what are all these. So first I go for propagation. What exactly is propagation? It is nothing but the way the radio waves travel or propagate when they are transmitted from one point to another and affected by the medium in which they travel, and in particular the way they propagate around the earth in various parts of the atmosphere. So I told you what is propagation is nothing but antenna is transmitting a signal. The way in which the signal comes and arrives at the receiver, if it has been disturbed by any interference, what happens to it? So that mechanism is called as propagation of radio waves, right? So I repeat, it's nothing but the way in which the radio waves travels from the transmitter to the receiver using all the interferences or coming out through the interferences. Then next topic, modes of propagation of radio waves. So how many modes are there? There are nearly 3 modes of propagation of radio waves. Number 1 is the line of sight. Line of sight is nothing but the direct communication. If your transmitter is here, your receiver is here, they're going to contact directly. That is called as line of sight propagation. The second one is ground wave propagation, wherein transmitter sending a message, it has been reflected in the earth's surface and then coming out to the receiver. So this type of propagation I call it as ground wave propagation. The last one is a sky wave propagation, where your signals go into the ionosphere then come back to the receiver, right? So this is what is sky wave propagation. Multipath propagation. So what does it word tell you? Multipath. But it's going to tell you that there are many paths for the waves to propagate, right? So multipath is a propagation phenomenon that results in radio signals reaching the receiver antenna by 2 or more paths. So a signal is going to reach a receiver by how many paths? By many paths. For example, if suppose consider a mobile over here, user 1 is calling to a user 2. They have been separated by certain distance, and while the wave is traveling over the lane, over the distance between user 1 and user 2, what are the elements will be present? Obviously, you will have certain lamp posts, you will have certain base stations, you will have many buildings over there, trees over there, and many vehicles will be passing over the road, right? So what happens when the signals start coming, or the signals will be coming and falling on all the things present over here. So the signal might fall over the lamp, might fall over the way stations, might fall over the buildings, might fall over the trees, might fall over the cars, and then only it comes and reaches the receiver. So a signal is falling on many obstacles and then coming, thereby you are getting many types of signals over here. So this concept is called as multipath propagation, right? So wherein it results in radio wave signals reaching the antenna by more paths. What are the effects of multipath propagation? So when I go back to the diagram present over here, so what is the effect over this, right? So look here, I have sent only one signal. That one signal is coming as 5 signals. So 1 has been multiplied as 5. So there is addition of the signals, right? So I call it as constructive. One effect is constructive, right? So 5 signals are coming, right? It is falling over the surfaces, it is falling over the lamp. So certainly there will be dispersion of the signals, right? But what has happened? Your signal has lost certain things. So I can tell it as technically as destructive. So what are the effects of multipath? They have a constructive and destructive interference, and again a phase shifting of the signal. And due to this interference, it goes for a concept called as fading. Okay, so to be in a nutshell, what are the effects of multipath? You have constructive, destructive, and phase shifting of the signal, right? Then next, fading. Before I could go into the concept of fading, let me tell you an example. Okay, think that I have purchased a jeans pant 2 years ago, right? Which is dark blue in color. After 1 year, the dark blue color has been turned into a light blue color, right? Then after 1 year, the light blue color has been turned into a dull blue color. Now what has happened as days has passed, the color, the quality of the jean pant which I purchased 2 years ago has been degraded, right? So now what are the reasons for this degradation of this pant from a dark blue color to a dull blue color? What might be the reasons? So I have 4 reasons. Number 1, I will be washing my jean pant, right? So the hardness of the water could be a reason for the dullness of the pant. Number 2, if I am putting it over the sun, over the hot sun for 3 days, what happens? The quality might get disturbed. And third, due to the temperature, the quality might be disturbed. Then last one, the soap or the detergent which I've used might be changing the quality of the jean pant. So due to these factors and due to the time nature, my dark blue color pant has been faded to a dull blue color pant. So have this as an example, have this concept as an example. We'll go to a wireless communication medium. So what is fading in wireless communication medium? Fading is a variation of attenuation of a signal with various variables, and these variables include the time, geographical position and radio frequency. So I could tell you that my signals are degraded because of the rain, are degraded because of the obstacles, are degraded because of the frequency of the signals. So degradation of a signal caused by these normal variables, I call it as fading. What are the propagation mechanisms in wireless communication? There are 3 basic propagation mechanisms. Number 1, a reflection, diffraction and scattering. So what do you mean by reflection? Reflection is nothing but if, look here, a signal is coming, it is falling over the surface of the wall, it is coming back. That is what is a reflection. Scattering, what do you mean by scattering? A signal is split up into many things, right? And diffraction, what is again diffraction? If it falls on any coarse objects, any harder objects or pointed objects, again a signal will be split up into many parts, right? So that is what is diffraction. We will see it technically in detail. Now, reflection is nothing but it occurs when the propagating wave impinges on smooth object. For example, see, look here, the wall surface is very smooth. When a wave falls on the smooth object, the wave get reflected. This is a reflection. Diffraction, see, when your wave, it goes and falls on a sharp edges, right? When a wave is falling on a sharp edge, it get diffracted. Okay, and scattering, what do you mean by scattering? It is nothing but when the propagating wave impinges on the rough surface, right? If the surface is irregular and they have more number of obstacles, your signals will be scattered. That process is called as scattering. So these are the 3 mechanisms present in your wireless communication medium. Shadowing, right? I could get the example in detail. See, look here, a router is present over here and your mobile, some 2 mobiles are there using this motor for its internet connection, right? So a certain distance, the router is over here and it is been situated some meters apart. Okay, so no disturbance, you are getting the signal. Same, if the router is over here, you have the mobile here, the same distance only I am having over here. If I keep any object between, due to the shadowing of this object, the power received will be very feeble by this mobile. So this concept is called as shadowing. So what is shadowing? It is a deviation of the power of the received electromagnetic signal from an average value. It is caused by obstacles affecting the wave propagation. So this is shadowing. Next, path loss, right? So what do I mean by path loss? There is some weakness in your signal. Okay, so from the diagram it is very clear that, for example, I am transmitting a signal which is of 20 millivolt, okay, or which is of 20 volt. Okay, so I am transmitting a signal which is of 20 volt. When it goes distance, what happens? The amplitude of the signal gets minimized, right? So actually what is happening? The strength of the signal or the information signal has been degraded. So certain parts, what happened? The signal has been degraded. And finally, come to the receiver, look here, it is coming up to some millivolt signal. See, I have sent a signal which is of 20 volt, but due to the long distance transmission, what has happened? The signal's amplitude has been very much minimized. So this is what is called as path loss. So path loss is nothing but the reduction in path density of an electromagnetic wave as it propagates through space. It is called as path loss. So that's all with this video. The other topics I will discuss in the next video. Thank you.